Hi everyone, welcome to Impact Academy. So today let us continue with the science and technology questions. Model paper. Last time we have seen till fifth question. Let us continue from the sixth one. So consider the following statements regarding nuclear energy in India. Okay. So let us see the facts about nuclear energy. So India's nuclear energy is the fifth largest source of electricity for India. Okay, which contributes about 3% of the total electricity generation in the country. Okay, remember all these facts. Very important. Nuclear energy is fifth largest source and it contributes to 3%. India has over 22 nuclear reactors in 7 power plants across the country and produces 6780 megawatts of nuclear power. Okay, so this is also important. 22 nuclear reactors, 7 power plants. Okay, what are the 7 power plants? You have to look into that also. Kalpakkam, Kudankulam. Okay, all those things. Naroda, Kakrapar, Tarapur, all those things. Try to just go through. And this is also important. How much of it actually? Okay, around 6780 megawatts. Fine. Okay. So in addition to this, one reactor, Kakrapar Atomic Power Project, has also been connected to the grid in 2021. Okay. So recently, this Kakrapar Atomic Power Project has been added to the grid. 18 reactors are pressurized heavy water reactors and 4 are light water reactors. So this is also try to remember. Out of these 22, 18 are pressurized heavy water reactors, okay, and 4 are light water reactors. Existing nuclear capacity 6780 is going to be increased to 22,480. So basically 22 gigawatts. Right now it is around 6.7. It is going to increase to 22.4 by 2031. So more nuclear power plants are planned in future, like what you have one in Andhra Pradesh. What is that? Kovur. Okay, Kovur nuclear plant is planned in Srikakulam, Andhra Pradesh, and in Haryana, a couple of nuclear power plants are planned. So all those are very important. So try to remember all these points. Now let us look at the question. So, so consider the following statements regarding nuclear energy in India. It contributes to less than 3% of the electricity total generation, which is wrong. We have just now seen that it contributes to about 3%. Okay, it is the fifth largest source and it contributes to about 3%. So this is wrong. India has over 50 nuclear reactors with 10,000 megawatts. No, this one we have seen that it has around 22 nuclear reactors. Okay, in total 7 plants, produce around 6780. So this is also wrong. Over two-thirds of the reactors in India are pressurized heavy water reactors. So out of 22, two-third will be around 14 something, right? So more than that, 18 reactors. Okay. So 18 reactors are pressurized heavy water reactors. So this is true. Okay. Over two-third are pressurized heavy water reactors. So how many above are correct? Only one. Okay. 6A is the answer. So hydrodynamic trapping, solubility trapping, and mineral carbonation are associated with. So the reduction of anthropogenic carbon dioxide in the atmosphere is crucial for mitigating climate change. Okay, CO2 capture and storage is considered as one of the most promising options for carbon reduction. This means the main means is the injection of CO2 into structural reservoirs in deep permeable geologic formations. Okay, so trapping mechanisms to trap this carbon so that in order to reduce the overall carbon load, trapping mechanisms for geological sequestration or carbon sequestration include hydrodynamic trapping, solubility trapping, and mineral trapping. Okay, so these are the three types of trapping. What is hydrodynamic trapping? CO2 is trapped as supercritical fluid or gas under a low permeability cap rock. Carbon dioxide, being less dense than the formation fluid, will rise buoyantly until it encounters a cap rock. So this is hydrodynamic trapping. Okay, trapping CO2 in the form of a fluid below the rocks. Solubility trapping. When CO2 is injected into a reservoir, a portion of the injected CO2 will dissolve in formation of water in the aquifer, and dissolution of CO2 per unit volume of water is a function of pressure temperature, salinity, etc. So no need to go into too much depth. So solubility is basically they are making the carbon dioxide soluble in water, and hydrodynamic means they are burying it under the rocks, and mineral carbonation, that is incorporation of CO2 in a stable mineral phase via reactions with mineral and organic matter in the formation. So over time, the injected CO2 will dissolve into the local formation water and initiate variety of geochemical reactions. Anyway, these are the three types of trapping mechanisms. Okay, so um, hydrodynamic trapping, solubility trapping, and mineral carbonization. Okay, these three are carbon sequestration techniques. So just now we have seen there are different ways to capture carbon and reduce the carbon load in the atmosphere. Okay, in situ, ex situ means taking it away from the particular its natural environment. In situ is doing it in the natural environment itself. So bioremediation is also reclaiming the particular land or the environment by using some form of biological organism or etc. So recently they are using some kind of bacteria to clear the waters. Okay, you release that bacteria in the water. That bacteria will clear most of the pollutants. Okay, that is called bioremediation. So in this particular case, it is called carbon sequestration and hydrodynamic trapping, solubility trapping, and mineral carbonation. So which of the following are the components of the global solar facility under the International Solar Alliance? So International Solar Alliance is also very important, and India is one of the what you can say founding what you say the initiative has been taken by India. Okay, so it's more important for us, and because we are a tropical country, we have more sunlight throughout the year. So, the International Solar Alliance announced that the global solar facility formed by it to stimulate investments into solar power projects is set to receive a capital contribution of $35 million. Okay, Indian government is considering $25 million investment as capital contribution in the global solar facility, in addition to the 10 million coming from the International Solar Alliance. So, as I said, India is a key player in this International Solar Alliance. So, out of this 35 million, $25 million is being provided by Indian government, and this is the global solar facility. So it's a payment guarantee mechanism expected to stimulate investments into solar projects. So the Solar Payment Guarantee Fund and the Solar Insurance Fund. So initiative taken by the ISA but not under solar facility. So these are the initiatives taken by ISA, which is the Green Grids Initiative, One Sun, One World, One Grid. This is also very important, frequently asked. Global Energy Alliance for People and Planet launched at COP26 with 10 billion US dollars. And the ISS program on scaling solar applications for agriculture use. So, so try to just go through these things and try to remember that these are the initiatives by the ISA, and India is a very key player. Out of the $35 million, $25 million is being given by India, and it has two components. Okay, this global solar facility. One is the Solar Payment Guarantee Fund, and one is the Solar Insurance Fund. Okay, now let us look at the question. Which of the following are the components of the global solar facility under ISA? Okay, solar payment guarantee fund is there. Okay, solar insurance fund is there. So these two things are there. We have seen just now. One is the solar payment guarantee fund and the solar insurance fund. So global energy alliance for people and planet scaling solar applications for agricultural use. So these things are initiative but of taken by the ISA only, but they are not under the GSF. Okay, global solar facility. So these are also ISA program for scaling solar applications for agriculture, and Global Energy Alliance for People, One Sun, One World, One Grid. These are also very important initiatives taken by ISA, but they do not come under the GSF. So only 1 and 2 is the answer. 8A. Okay. The Solar Payment Guarantee Fund and Solar Insurance Fund are only part of the global solar facility under the International Solar Alliance. And out of the $35 million, $25 million is being funded by India. So consider the following statements regarding resilient and inclusive supply chain enhancement. Okay, RISE. So let us look at what is RISE. So resilient and inclusive supply chain enhancement or RISE was launched by World Bank and Japan joined by Italy, Republic of Korea, Canada, and United Kingdom. Okay, so these are the what is the organizations and countries involved: World Bank and Japan and Italy, Korea, Canada, and United Kingdom. So resilient and inclusive supply chain enhancement or RISE initiative will help emerging markets and developing countries increase manufacturing of clean energy products and boost their participation in the minerals industry, leading to quality local jobs and economic growth. So basically, it is talking about supply chain enhancement. Okay, increasing manufacturing of clean energy products in developing countries, okay, emerging markets, and boost their participation in minerals industry. Okay, try to remember all these things. What is the rise about supply chain, minerals, clean energy products, etc. And what are the companies? I mean, what are the countries apart from World Bank? It is Japan, Canada, Italy, Korea, and UK. Okay, initially they have contributed 40 pledged $40 million. The energy transition will create a $1 trillion market with tens of millions of jobs along global mineral value chains. It represents opportunity for EMDCs, which are emerging markets and developing countries to build manufacturing capacity, etc., etc. So basically, it is talking about mineral exploration, clean energy, etc. So, consider the following statements regarding RISE, Resilient and Inclusive Supply Chain Enhancement. So, it is an initiative of the Organization for Economic Cooperation and Development. It will help the emerging markets and developing countries increase the manufacturing of clean energy products. So, this is correct. Okay. So, this is clearly correct. We are talking about emerging markets and developing countries. And regarding this, it is an initiative of World Bank, okay, along with Japan, Italy, Korea, United Kingdom, and what else we have seen? United Canada, okay, World Bank, Japan, Italy, Korea, Canada, and United Kingdom. Not related to economic cooperation and development, okay. OECD, Organization for Economic Cooperation and Development, that's also very important. But RISE is not related to that. It is related to the World Bank, and it is exclusively for supply chain management, okay, and mineral exploration, clean energy for developing and emerging markets. Fine. Okay. So, 10th question. So, arrange the following gases according to the global warming potential in ascending order. So, from low to high. So, if you look at these various so carbon dioxide, methane, nitrous oxide, okay, hydrofluorocarbons, chlorohydrofluorocarbons, etc. Okay, and global warming potential in 20 years, 100 years. So you can see which is high. This 34,900. Okay, sulfur hexachloride is quite high, and which is low. Carbon dioxide is low. Okay. So what are greenhouse gases? Greenhouse gases are a type of gas that traps heat in the atmosphere. Okay, and because of this heat, it's causing the global warming. So whatever heat we are getting from the sun, that is trapped in the atmosphere because of these greenhouse gases. Some of the most common greenhouse gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. Okay, these hydrofluorocarbons and all these things. Okay, perfluorocarbons. So all these things. So carbon dioxide, nitrous oxide, and fluorinated gases, they are greenhouse gases. Even water vapor, okay, in the air is a greenhouse gas. Global warming potential is a metric used to compare relative impact of different greenhouse gases on global warming. Okay, different. So whether carbon dioxide is more or whether HFC is more, CFC more, that is the global warming potential. So if you look at carbon dioxide, So carbon dioxide is one of the primary greenhouse gases responsible for global warming. Okay, this is very important. Carbon dioxide is the primary greenhouse gases. Global warming potential is a metric used to compare the relative impact we have seen, right? So the global warming potential of carbon dioxide is 1. That is, it is the reference point for all other gases. Okay, and if you see, for example, methane has GWP of 21. That means it traps 21 times more heat than the amount of carbon dioxide over a 100 of period. That means if carbon dioxide is trapping one quantity, one unit, similarly methane is trapping 21 times more. Okay, so carbon dioxide is taken as a standard, and usually they are calculated over a 100-year period. Okay, so carbon dioxide is the primary greenhouse gas. So if you look at methane, methane is also greenhouse gas, which is about 56 times more potent than carbon dioxide. Okay, so frequently questions are asked about methane. Okay, methane is released into atmosphere because of wetlands, wildfires, termites, agriculture, landfills, oil and gas production. Usually, even cattle. Okay, cattle is also cattle rearing is also one of the standard source of methane. Okay, remember agriculture, landfills. Okay, landfills, when you dump everything, when it starts decomposing, lot of methane is released. Oil and gas production, and also what is a cattle rearing. Okay, lots of cattle, all the cattle produce methane gas, and wetlands, wildfires, termites, etc. And nitrous oxide is also a greenhouse gas, which is 280 times more potent. Okay, and nitrous oxide is through fertilizers. Okay, most of the fertilizers we use have NPK, right? Nitrogen, phosphorus, and potassium. Manure, irrigated agriculture, industrial sources like nitric acid production, etc. All those are one of the what is a major source of nitrous oxide. So hydrofluorocarbons is one of the what is a very potent greenhouse gas. It will, the Montreal Protocol and all those protocols are mainly for reducing or eliminating hydrofluorocarbons. Okay, so they are used as refrigerants in foam blowing applications. They are very potent greenhouse gases. Okay, and there are thousands of times more potent than carbon dioxide. That is why they were able to cause a hole in the ozone layer also. They are not naturally occurring, and they are released due to this refrigeration, air conditioning. Okay, foam blowing. HFC are used in foam blowing application, such as in production of insulation and packaging materials. So these days, HFCs are not. They are banned from used to be used in refrigeration and air conditioning. Okay, now they are using hydrofluorocarbons. Okay, CFCs and HFCs are banned. Hydrofluorocarbons are still being used. Okay, next sulfur hexafluoride. It's also greenhouse and it is 23,000 times more potent. And it is also not naturally occurring in the atmosphere, and it is mainly released due to electrical equipment. Is used as the insulator in electrical equipment such as power transformers and switchgear. Okay, sulfur hexafluoride. So try to remember the order. First, carbon dioxide. Carbon dioxide is the basic unit of 1, followed by methane, nitrous oxide, hydrofluorocarbons, and sulfur hexafluoride. Okay. So now arrange in the following order, in ascending order. So low to high. We know that lowest is carbon dioxide. So it has to start with 4, either B or C. Next highest is methane. So 4, 2. So C is the answer. Next 1, which is nitrous oxide, followed by sulfur hexafluoride. Okay. Carbon dioxide, methane, nitrous oxide, and sulfur hexafluoride. Okay. So we have also seen the sources and everything. Okay. So global warming is a very important topic. So we'll continue in the next class with the 5 more questions. Thank you.